All right, we're going to talk about composing inverse trig functions. So if you remember last semester when we talked about composing functions, we said if you take a function and compose it with its inverse, what comes out? X, right? So is that going to always be true for a composing sign with inverse sign? Is X going to pop out? The answer is sometimes. Not totally as easy as it seems because of our restricted domains, right? So don't think about this being sine X, just think inverse sine of anything. What are the possible things that could come out? Well, it has to be something between 0 and 1. I mean, negative 1 and 1, right? That is the range of inverse sine. So whatever we put in, we can put anything in here, right? So if the thing we put in here is outside of our range of sine inverse sine, it can't come out. All right, so this is abstract right now. Let's look at some examples. All right, what about inverse sine of pi thirds? Okay, well, the easiest thing to do is, let's say, what is sine of pi thirds? Sine of pi thirds is square root of 3 over 2, right? Okay, well, what's inverse sine of square root of 3 over 2? And the answer is pi thirds, right? This is always going to give us a angle between negative pi and pi in quadrants 1 or 4, right? So the inverse sine of square root of 3 over 2 is pi thirds. So if we compose those two together, sure enough, X pops out. What about this next example, sine of 2 pi thirds? Okay, well, sine of 2 pi thirds is square root of 3 over 2. What's the inverse sine of square root of 3 over 2? Inverse sine of square root of 3 over 2 is pi thirds. Okay, we're always going to get an answer in quadrants 1 or 4. Okay, so if we compose those two things together, the answer is also pi thirds. So it's not just as easy as looking at what you're taking, what the X value is. Okay, you have to evaluate this inside function and then take the inverse trig function of that thing. So cosine of 2 pi thirds. Cosine of 2 pi thirds is negative 1/2. What is the inverse cosine of negative 1/2? It's 2 pi thirds, right? This is kind of a trick question, trying to trip you up. Because inverse cosine is defined on quadrants 1 and 2. So the inverse cosine of 2 pi thirds of negative 1/2 is 2 pi thirds. How about this? Inverse cosine of negative pi thirds. Well, what's the cosine of negative pi thirds? Here's negative pi thirds. Cosine of that is 1/2. What is the inverse cosine of 1/2? We're looking for something that has this value that's in quadrants 1 and 2, and the answer is positive pi thirds. Okay, so the easiest way to do this is evaluate the inside function and then evaluate the outside function. You got to really do it in 2 steps. If you're lucky, then this number is just going to pop out, but it doesn't always happen. All right, what about this? Inverse sine of cosine of 13 pi 6. Okay, let's evaluate the inside function. Cosine of 13 pi 6. Well, if we can find a coterminal angle for this, right, which is pi 6, just by subtracting 2 pi from this. And cosine pi 6, we know that from our tables. Cosine of pi 6 is square root of 3 over 2. Well, inverse sine of square root of 3 over 2 is pi thirds. Okay, you can see why knowing your table values are essential to solving these problems. There's not another way to do it other than to know the values on that table. Okay, you have to know those values. Okay, well, what if we have something like this? Inverse cosine of 4/5. This is not one on our table. So how can we solve this? And we want to find an exact value. So we don't want to just stick this in our calculator and see what comes out. Okay, so let's look at this. Oops. I'm going to write this down. Sine of inverse cosine of 4/5. All right, so there's going to be a 5-part process. Here's the first thing we do. Just look at the inverse, the inside function. Inverse cosine of 4/5 equals some theta, right? We don't know what it is, it's some angle. All right, step 2, write it like this. Cosine of theta equals 4/5. Okay, so we're just rewriting this equation in that form. Step 3, we're going to draw a triangle, a right triangle, and choose a theta. It could be either angle, you just got to write it down and stick with it. Okay, well, here's our theta. So cosine of theta is adjacent over hypotenuse. Right? All right, we have a right triangle. We know 2 sides. We can find the third side. So that's our 4th step. We're going to say, let's call this A. A squared plus 4 squared equals 5 squared. A equals the square root of 25 minus 16. So that's 9. So A is 3. Right? We could have noticed that this is going to be in Pythagorean triple, 3, 4, 5. But if you don't, no problem. You just use the Pythagorean theorem. Okay, so now our 5th step is we write sine of theta equals what? Well, sine of theta is opposite over hypotenuse. So 3/5. There's our answer. Okay. So first, we write our inside function. Then we write it like this. Then we draw our triangle, label the 2 sides that we know. 4th step, find the 3rd side. 5th, look at our original question and find that trig ratio. All right, let's do another one. I'm going to write, well, let's find sine of inverse tangent of 7/4. All right, let's do the same process. First, I'm going to just look at this inside function and say it equals theta. Second, I'm going to write tangent of theta equals 7/4. Third, I'm going to draw my triangle. You gotta draw your triangle. If you don't draw your triangle, you're going to get super confused. All right, tangent of theta is opposite over adjacent, so 7/4. 4th step, we're going to solve for our 3rd side. Let's call this A. A squared equals the square root of 7 squared minus 4 squared, or plus 4 squared, sorry. So A equals the square root of that. So 49 plus 16, so that's 65. So A equals the square root of 65. 5th step, we're going to find the sine of theta. Okay, well, sine of theta is opposite over hypotenuse. So 7 over the square root of 65. We want to rationalize that. We're going to get 7 times the square root of 65 over 65. Got it? Okay, last one is going to get a little more abstract. What if we want to find the cosine of the inverse sine of x over 3? For x between -3 and 3. All right, same process. First, I'm going to write inverse sine of x over 3 equals theta. Now I'm going to rewrite this. I'm going to say sine of theta equals x over 3. Now I'm going to draw my triangle. There's my theta. Sine is opposite over hypotenuse, so x, and that's 3. 4th step, I'm going to solve for a, my other side. Okay, well, a squared plus x squared equals 3 squared. So a is the square root of 9 minus x squared. Great. 5th step, I'm going to say cosine of theta equals adjacent over hypotenuse. And that's my answer in terms of x. And we had this restriction here that x is between -3 and 3, so that we know that this is positive, or it is the positive value, so it's real, right? We're taking the square root of a positive number. Okay, so a little more abstract, but the exact same process.